Okay, today we're looking at Module 4, Lesson 27. The beauty of Lesson 27 is it's the exact same thing as Lesson 26. In Lesson 26, we were trying to find the value of the variable. B equals what? X equals what? And the equations that we looked at on Friday were addition and subtraction. So when we solved algebraically, what did we do to find the value of the variable? If it was adding, we had to subtract. If it was a number being subtracted from a variable, we had to, and what was that called? We used the inverse operation to solve. So inverse means opposite, so the opposite operation to solve. So today, if we're looking at multiplication and division equations, if the variable is being multiplied, what are we going to do to solve it? Divide. And if the variable is being divided, what are we going to do to get the identity back? Multiply. So you already know how to do it. And then what do we do to make sure it was correct? We have to do the check. So today we're going to practice tape diagrams and solving algebraically to find, gentlemen, the value of the variable. So let's take a look at the first equation. The first equation is 3z equals 9. Well, I don't want to know what 3 z's are. I only want to know what 1 z is. So I could draw my tape diagram like this. 3z is on the left, and 9 is on the right. But does that tell me what 1z is worth? So I could expand that out. So what I really could draw, z, z, z equals 9. So does that show 3 z's equals 9? But can I figure out what 1z is by looking at that tape diagram? No. So let's match that up a little bit and see if we could do it a little bit better. So here, gentlemen, so I still have my 3 z's, and I still have my 9, but instead I'm going to separate my 9 into 3 groups. What operation is that when I take a number like 9 and separate it into equal groups? Division. So I'm taking my 9 and dividing it by 3. Hey, look at this. I'm taking my 9 and dividing it by 3. Keep that in mind when we solve algebraically. So what is my 9 divided into 3 equal groups? 3. So what does 1z equal? 3. So that's how you draw a tape diagram to represent the division, to solve it algebraically. So now let's solve this algebraically. You all told me that we took this 9 and we divided it into 3 equal groups. That's exactly what we're doing algebraically. So the first step, what's always the first step when we're solving algebraically? Excellent. Rewrite the original equation. So 3z equals 9. 3 is my coefficient, z is my variable. When I see a coefficient and a variable next to each other, what operation is there? I don't even have to write it. What operation is there? Multiplication. So to solve this algebraically, I have to use the inverse operation. What is the inverse operation of multiplication? Division. So I'm going to divide both sides. By what? What am I going to divide both sides by? I don't want 3 z's. I just want 1. By 3? Yeah, by the coefficient 3. So 3z divided by 3 equals 9 divided by 3. Hey, 9 divided by 3, isn't that what we did in our tape diagram? We took our 9 and divided it into 3 equal groups because I had 3 z's. So here's some 9 for this z, here's some 9 for this z, and here's some 9 for the last z. That's what we did in our tape diagram. So we remember back from lesson 1, 3 times z divided by 3. When you have a variable and you're multiplying and dividing by the same number, you get that variable back. You get that identity. That's from way back in lesson 1. So 3z divided by 3 equals z. 9 divided by 3 is 3. 6. So now we want to make sure we didn't make a mistake. So we'll check it. To check it, we always start by writing the original equation. Now I'm going to write it again, but now I know what z is. So instead of writing z, I'm going to write 3. And I know that when I see a coefficient and a variable like 3z, that means multiplication. So I use a dot or parentheses. Don't use an x because then it's going to look like another variable. And you'll be like, wait, what? Where'd that letter come from? 3 times 3 is 9. Bring down the equals 9. Since that's a true statement, x does equal 3. But now suppose I accidentally over here multiplied. Suppose I multiplied and got 27. When I did my check, 3 times 27 would have been 81 equals 9. Does 81 equal 9? No, so that means x does not equal, or z does not equal 27, so I'd have to go back and find my mistake. So you want to make sure your left and your right match, so you can go back and find a mistake. All right, let's try another one. Now we have y divided by z equals 2. Imagine this whole pizza. My whole pizza is y. So I took my whole pizza y, you're just looking right now, and we divided it into 4, right? So my y divided by 4 looks like that. Yes? This is y divided by 4. It's 1/4 of the y. What does 1/4 of the y equal? What does 1/4 of the y equal? 2. So I know that this is 2. That's 2. That's 2. That's 2. Whoops, that's moving. And that's 2. So what's my whole thing going to be? 8. So let's take a look at what that would look like in a tape diagram. So first, we know that, I'm going to draw it down here, y divided by 4, that equals 2. But is that really helpful? No, I need to know what y is. So let's draw a large y. God bless, God bless. So we have y divided by 4. Why did I draw 4 boxes to equal y? Why did I take y and divide it into 4 boxes? Yeah, it's y divided by 4. So I need 4 boxes to equal that whole y. I know that y divided by 4 equals what? Y divided by 4 equals what? 2. So each one of those equals 2. That was given to us. Y divided by 4 equals 2. I know that from the given equation. What do all these 2's add up to? 8. So what does y equal? Y equals 8. My top box matches my bottom. Now let's solve that algebraically. So we always start by writing our original equation. Can we write it that way instead of a fraction? You can write it either way. We know that the fraction bar means division. So y divided by 4 equals 2 is the same thing as y divided by 4 equals 2. You can write it either way. So if it's being divided by 4, what do I have to do to get the identity back? Yeah, by 4. Whatever I do on one side of the equation, I have to do to the other side of the equation. So y divided by 4 times 4 is y. 2 times 4 is 8. I got the same thing. So to check, the first step we have to do is write the original equation. Now I know what 8 is, so I can replace y with 8. 2 equals 2. Or if you wanted to solve it this way, fraction bar means to divide, so 8 divided by 4 is 2. 2 equals 2. So you can write the equation either way. If you don't like it written as a fraction, you could write it using the division symbol. Okay. Before we go on and practice one, actually let's just practice 1 and 2, then we'll jump ahead. We have time to get it done. So 3m equals 21. It wants us to use the tape diagram. So let's do that. 3m's equal 21. I wonder if 3m's are better than m and m. So, can you imagine what that can't even be? Oh my goodness. Okay, so 3m's equals 21. Write it down. Gentlemen, come on, please. So now, I'm going to take my 21 and divide it into 3 even groups because I have 3 even groups of m. So what is my 21 divided into 3 equal groups? 7, 7, 7. So what does m equal? 7. So to do my check, 3m equals 21. M is 7. Now please make sure that whatever operation, computations you're doing in your check, you actually write it out. Because so many times kids will be like, oh, it has to equal 21, and they just put it down, which defeats the whole purpose of the check. You have to actually do the computations. Don't assume it will equal what it's supposed to equal. Because if it doesn't equal what it's supposed to equal, then that's your red flag that you made a mistake. Go back and fix it. Get it right. Okay? Number 2, let's solve this one algebraically. Now, I know if my daughter was doing this one, she would not like the way it was written. How come? Well, the answer's first, and we're not used to seeing like the 15 first. So if that's freaking you out, and you want to do n divided by 5 equals 15 and rewrite it that way, you can. It doesn't matter. It means the same thing. But that would totally throw my daughter off. She would not like that. Right? The wrong way! No, it's not. It means the same thing. Okay? But how many of you are more comfortable with it this way? Yeah. I get it. I get it. No matter which way we solve this, right now, n is being divided by 5. Fraction bar means division. So what's my inverse operation? So I'm going to multiply both sides by 5. So 15 times 5 equals n divided by 5 times 5. You can write it that way. Or if you wanted to do n divided by 5 times 5 equals 15 times 5. It doesn't matter which way you write it. It means the same thing. You get your identity back. 15 times 5 is 75. N equals 75. God bless you. Now for the check, you write the original equation. N is 75, so I replace my n with 75. Now, so many times, normally, a lot of us can't do mentally 75 divided by 5. Or then, remember, we start with the smaller problems so that we know how to solve the bigger ones. Don't assume 75 divided by 5 equals 15 and just put down 15. Go to your margin, do the computations. Make sure that they really do equal each other. Because if they don't, you made a mistake somewhere and you need to backtrack. Okay? Where's your check? You're missing all of your checks. Your notes are sorely lacking, my friends. And you're going to struggle when you do your homework, and you might struggle on your quiz, which I hope is not the case, which is why I want you to cover your notes. Oh, if I write it, you write it. There. Jump to number 4. Jump to number 4. They drew the tape diagram for you, gentlemen. They drew the tape diagram for you, but there's no equation. You have to come up with the equation. So I see 2 tape diagrams that are equal. The top is equal to the bottom. I know that because they're the same size. So what equals what? What's my top box? 70. What is this that equals 70? What equals 70? There are 7 Q's that equal 70. Do you want to solve that? Please. Do you want to solve that algebraically or with the tape diagram? Algebraically. I agree. So how do I solve that algebraically? If that's 7 times G,
7 divided.
I'm going to divide both sides by 7. Is anybody not sure like what you're dividing both sides by or what you're multiplying both sides by? So whatever your coefficient is or whatever is being divided by, that number that's hooked up to your variable. So Q equals 10. Check. True. Q does equal 10 because both sides of my check are equal. All right, let's do number 3. Do you want to do a tape diagram or algebraic?
Algebraic.
How many of you feel like you need more practice with the tape diagrams, though? All right, let's do a tape diagram. So I have 4 P's. That's better than I have 2 P. So I have 4 P's. My 4 P's equal 36. So I took this side and wrote it here. I took that side and wrote it there. Are we okay with how I drew my tape diagram? Yes? Are we okay with how I drew my tape diagram? Okay. Now, I want to take my 36 and make it into 4 sections like the tape diagram above it. So now I'm going to take my 36 and break it into 4 even pieces. So what is 36 divided by 4? 9. See, I like the tape diagrams because when I was growing up, I was just told, use inverse operation. This is how you do it. And I didn't know what it meant. I didn't know why I was doing it. Tape diagrams can be annoying, but I like that it's showing you why am I dividing both sides by 4? why am I doing this? 4p divided by 4 equals 36 divided by 4. Shh, there's your algebraic. So p equals 9. So the tape diagrams give you a nice visual of what the inverse operation means. And then, of course, we write our original equation to check. Always, it doesn't matter if you use your tape diagrams or if you use your algebra. You always start with your equation.